Today we're going to be talking about the one-to-one functions and the horizontal line test. So we're going to start with a classic function. It's a parent function, x squared. I'm just going to plot some points. What the heck? 0 squared is 0, 1 squared is 1, negative 1 squared is also 1. Be careful if you type that into your calculator. Put parentheses around the negative number. Okay, and then 2 squared is 4, and negative 2 squared is also 4. So up 1, up to 4, which is up 3 more. So normally we go up 1, and then up 3 more, and then up 5 more, and so forth. Next notes, I will be taking a look at something that gets a little steeper, and we'll talk about the pattern for that. If I'm looking at the inverse function, again, to remind you, we're switching output and input to undo what the original function did. So I'm going to have 0, 1, 1, 4, 4 for inputs. And the original inputs become outputs. So if the original graph looks like a parabola, the inverse looks like, well, let's see, 0, 0, 1, 1, 1. Ooh, this fails the vertical line test. Okay, and then 2, 4, and negative 2 also 4 as input. Okay, so looking at this, a full sideways parabola is not a function. If the new inverse fails the vertical line test, the original failed the horizontal line test, which is what some people were thinking would be making it not a function. It's still a function, but it's not one-to-one anymore. One-to-one means one input for every one output. So let's write this down. Okay, it's written as 1-1, and it's pronounced 1-1. So x squared is not 1-1. Okay, so x squared is a function, which you should be thinking of as like a button on the calculator. It either gives a number or it says error. An error is okay, but giving two different numbers would not be okay. The full sideways parabola is plus or minus root x. Notice half a sideways parabola is what square root of x normally looks like. Hope you don't mind if I didn't talk for a while. Okay, so the inverse of squaring is square rooting, but we're going to be obsessing a little bit about the fact that whenever you take a square root, you always have to at least consider plus or minus. And the plus or minus is what makes it not a function. Now, it doesn't have to be x squared in order to fail being a function. Let's graph this thing people were not doing too well at graphing these inverse functions. So let's take a more detailed set of points. I'm going to call this first point -5, 10-ish. This one I'm going to call -1, 10. This one I will call 1, 10. Okay. But besides those, which give me a partial view of what's going on. Notice that since there used to be 10, 20, 30 on the y-axis, it's now 10, 20, 30 on the x-axis for F inverse. Oh. Okay, so at 10, we have, let's see, let's make it go 2, 4, 6, 8. Okay, 10, -5, 10, -1, and 10, 1. Okay, but it doesn't make it very easy to tell anything except that a horizontal line got turned into a vertical line. So let's plot a few more points so that we can see which way things are going. I'm going to plot the x-intercept, which looks like it's at, well, if that's -5 here at height 10, this is probably -5.2-ish, something on that sort of order. So 0, negative, just a little bit further down than what it was at 10. 10, -5, 0, -5.2, fine. It also says plot the y-intercept, which looks like it's about halfway up. So I'm going to call that one 0, 5. So let's plot that one. So 10, 20. Okay, so 5, 0 would be halfway to 10. Okay, so let me draw these in blue so you can tell. All right, so, and a few more things. Let's see. I said, let's go ahead and do the maximum here. That looks like it may be halfway between -4 and -2, so -3-ish. And then halfway between 20 and 30, 25, sure. Okay. Good thing we organized our x coordinates here in multiples of 10. So -20, okay, 3 is about here. And we had that x-intercept. And, sorry, 25, -3. Just screwed that up. Hold on. 25, -3. So 25, -3. Oh, okay. So that's what's happening, is it's going up in the fourth quadrant and then feeling. Remember that the symmetry is not rotation, it's reflecting across the line y = x.